Hello everyone, and in this video we'll be talking about comparisons, Boolean operators in NumPy, and how we can use Boolean as mask in matrices and vectors. So let's get started. Okay, let's say I have a variable x and I create an array of 1, 2, 3, 4, and 5. Let's print this. We get an array of 5 elements. Now, comparison operators normally the way we use it in normal Python. Similarly, it is used over here. And again, every operation is element wise operation. So if I write x is x less than 3, then it will give me a value of true, false, false, and false. So if you see only 1 and 2 are less than 3, else everything is either equal to 3 or greater than. Similarly, if I say x is greater than equals to 3, what will I get? False, false, because these two are neither greater than or equal to 3, and I get true, true, true over here. Now let's say I want those elements in a large data set where you can't see every element. How do you pick out which elements do you do? When we learn pandas, there is also many different ways in which you can do it. In NumPy, let's say you have a large data set and you want uh, some element which is less than 3. So what you will do is you can say x, and within third brackets we can pass in s, x is less than 3, and it will give me those elements which are less than 3 in an array form. This works in all vectors and matrices as well. Okay, so working with Boolean arrays. Let's say I create a matrix x, okay, which is equal to, let's do something like this. RNG is equal to np dot random dot default range speed is equal to 42, and we'll say x is equal to rng dot integers s with 10 elements having size is equal to 3 comma 4. Fine, 3 comma 4, and let's print x. So I get this. This 10 doesn't mean 10 element, it means 0 to 10. You have to, the range is from 0 to 10. Okay? So I get this array. Now what does this means? This, if you don't understand, it's fine. It's basically what it's doing is it's keeping this array constant. When you normally use range or any random function, every time you run the command, the matrix changes. So if I would have used a normal range and ran it again, the matrix would have changed. But using seed, what it does, it keeps the matrix constant. Okay, so if I write x again, x is less than 6, so it gives me the Boolean values. Now how many values are there which are less than 6? You can use np.count non-zero, because we are not including 0. Okay, and then we'll say x is less than 6. It gives me number, of course, because we are counting. Then let's say I do np.sum all the elements which are less than 6. So it sums up all the elements which are less than 6. Now let's move on and talk about and or operators in NumPy. What is the basic difference between and or operators? Let's say I write bool 42, it's true because it's greater than 0, and I write bool 0, it will be false, of course. Fine. What if I write bool 42 and, like the word and 8 or 0? So it will be false, because some true false is false for and operator. Similarly, if I write bool 42 or 0, it will give me true. Now using binary values of 42, gives me the binary of 0 or 59, let's say, because 0 is 0, so let's use a different number. 59, I give another value. What if this time I use bin or bin of 42 and the symbol ampersand symbol and 59? I get this value, and bin 42 this and 59, I got another value. This is AND operator bitwise. Even if I don't use bin, if I write 42 ampersand 59, it will give me 42. Okay, so how is this 42 coming? If you see this thing over here, binary of this is equal to binary of this. So it's a binary operation. This thing is a bitwise binary operation. This one deals with the number, the integer number. Okay, this is it for today's video. In later videos, we'll explore how we can use bool and or, ampersand and or in actual real world data set, and also how we can index out and filter things for there. Okay, so thank you for watching. I'll see you in next video.